Good morning, students. Happy Wednesday. So we are going to go through 3.05 domain and range day 2. Hi, so go ahead and pull up that Go Formative. If you don't have it pulled up, go ahead and pause this so you can get it pulled up. Your guys' warm up today is a light bulb is turned on, uses 360 kilojoules of energy per hour. The bulb is kept on for 3 hours. Consider a function that models the energy used in kilojoules as a function of time spent in hours. Which of the following statements about the domain and range of the function is not true? Okay, so the first one says the domain is the set of all the hours the bulb is used for. Okay, that's your domain because that'd be your independent variable. Remember, time can always be independent. Range is the function, the range of the function is the set of all possible amounts of energy used by the bulb. That's true. That's what we're trying to compare it to. That's what it depends on. The domain is all real numbers. Okay, so mean all real numbers, that means it can be positive, it can be negative, it can be decimals, it can be from negative infinity to positive infinity. Okay, that one's not true. It makes no sense to have negative hours. Okay, so it cannot be all real numbers. And if I look at it, it says it's only kept on for 3 hours. So we're going to have from 0 to 3 hours. And it could be decimals in there, but it's only going to be from 0 to 3. And then it says the range is from 0 to 1080 kilojoules. So if we took that, so 0 times our 360 kilojoules, 0 hours times that would be obviously no energy is given off. Then if we take 360 times 3 to get our maximum amount of energy that was used, that gives us 1080 kilojoules. So our class notes for today are similar to yesterday. So we again are looking at domain and range. So remember, domain left to right, range lowest to the highest. So this is our first function. This is the equation for it, so 8 minus 0.5x. So the domain for this function, if I look at the graph, so remember left to right, the furthest left point is over here. Bring that down to the x-axis, and that is at 0. Then the furthest right point is all the way at 16. Then you want to look at the lowest to the highest, lowest down here, drag that over to the y-axis, that's at 0. And then the highest is at 8. Okay, so that's how we would find our domain and range for that function. In a table, it looks a little bit different. Again, we're still looking for the lowest x value and the highest, and then the lowest y value, highest y value, okay, or input output. So in our table, we can see here the independent variable goes from 0 to 40, and the range, even though it starts at 2000, remember you want to find the lowest first. You should always put them in numerical order. So we have 0, and then the highest one is at 2000. And they could be somewhere in the middle. It doesn't have to be just the beginning and end. For linear functions, it will be the beginning and end, but for other functions, it could not be. Another example here, this one is a infinite linear graph, meaning that it has an arrow. So if we look here, this is our function. It says, suppose Jim charges $40 plus $25 per month. Okay, so this is the graph of it. So domain first, remember left to right. Okay, so the furthest left is at 40. Okay, but that's a y value, remember. So you have to bring that down to the x-axis, which is at 0. So the lowest x value is 0. And then if I go to the right side of the graph, I see an arrow. So anytime you see an arrow, there should be some sort of infinity. And if I drag that down to the x-axis, that arrow is pointing towards the positive direction. So it would be positive infinity. Then for the y values, the lowest y value is at 40 because that's actually your y value. And then again, that arrow means some sort of infinity. If I drag that over to the y-axis, that's going to positive infinity. And technically, these should be parentheses because you cannot include infinity. Okay, but we can talk about that during class. So our first example here, it says, what is the practical domain and range for this? Okay, so you can read the story about the amplitude and the Fahrenheit. So if we look at this, our amplitude is what determines our Fahrenheit, so that's our independent variable. So if I look here, the lowest value is 0 to the highest value, which is 2000. So your domain would be 0 to 2000. So that would be A. And then your range, we have to actually look. Okay, remember what lowest to highest. So the lowest value I see here is 11, and the highest value I see here is 59. So it'd be 11 to 59. So that would be D. The next one, we are looking at a graph this time. So we have the graph shows the plot of a number of marbles in a jar and the weight of the jar. Okay, so the marbles is the independent variable, which determines the weight. So we have our x's down here. So we want to find the domain first. We want to look left to right. So the furthest left point on our graph is right here. Drag that down to the x-axis, that's at 0. Then if I go to the other side, that's the furthest right point, and it's got an arrow. So remember, arrows mean some sort of infinity. Drag that down, that's pointing towards positive infinity. So the domain would be 0 to infinity. Then our range here we can see is we want the lowest to highest. So again, look down here. We have the lowest, which is about halfway between there. So I would say 10, higher somewhere near 10 if you're looking at your choices. And then the highest point is up here, which is an arrow. So that means some sort of infinity that's going up. So it has to be positive infinity. So it should be 10 to infinity. So the first one would be C, and the second one would be B. Here's another graph. The Vance charges $20 per hour to plow snow off the driveways. The cost of his customers can be plotted against the number of hours he plows. Okay, so again, your hours, time is independent on your cost. Okay, so if we look at the domain, so left to right, so the furthest left is at 0 right there. And then I have a arrow, which is pointing to the right. So that has to be positive infinity. And then the domain also, or sorry, the range also starts at 0 on the y-axis. And then again, that arrow at the top is going up. So that would be positive infinity. So both of those are 0 to positive infinity, which is C. Okay, and you can see here that they have those parentheses now. Again, we can touch base on that when we get back to class. Okay, the next one, it says at dawn, the temperature was 8 degrees and steadily rose 2 degrees every hour. The temperature was plotted against the time. Use the graph of this linear relationship to complete the sentence below. Okay, so we want to make sure we're looking at the domain and range. So again, domain left to right. So furthest left point on my graph is right here. Drag that down to my x-axis, that's 0. And then on the right side of the graph, I have an arrow, so some sort of infinity, and it's pointing to the right, so that has to be positive infinity. So that one would be 0 to infinity. Our range, remember y values, is lowest to highest. So the lowest point is right here at 8 on the y-axis. And the arrow up here is pointing up. So it's going to go to positive infinity. So it should be 8 to positive infinity. So we have 0 to positive infinity and 8 to positive infinity. Okay, so always make sure that you're looking at domain as your x value, so left to right, and then your range is y value, so lowest to highest. And if you guys ever get stuck on which one is which, I always remember put them in alphabetical order, so domain, range, x, y. I want you guys to complete the breakout room problems 10 through 13 on your own. If you have any questions, please email me, and I will also go through and give you guys some feedback as well. Make sure you click your exit ticket for me. Your guys' homework is an OHS quiz, so 3.05 OHS. I will see you guys tomorrow.